Today we're going to talk about LeetCode question number 279, serialize and deserialize binary tree. So serialization is the process of converting a data structure or object to a sequence of bits that can be stored in a file or memory buffer. So basically it's saying object to string. That's what serialization is. Design an algorithm to serialize and deserialize a binary tree. There's no strict restriction on how your serialization or deserialization algorithm should work. You just need to ensure that a binary tree can be serialized into a string and can be serialized to a string and can be deserialized into the original tree structure. Okay. So yeah, this is kind of a free form question where the output doesn't have to exactly match here, as we can see. So basically we just need to be able to convert this binary tree to a string, any string format we want, and using that string format we should be able to get the original tree structure. Okay, so I think for serialization I think the easiest path is to do a in-order traversal, or sorry, a pre-order traversal of the tree and store it in an array, which we can later convert to a string. Okay, so how would this pre-order traversal look like? Well, of course, we'd start with the root node 1. Okay, pre-order, remember, it means visit the parent node first, then the children node last. Okay, and then next we would, so it would be like parent, left child, right child. Okay, so we visited parent, now we look at the left child. Okay, 2, and we look at 2's left child, and it turns out to be none here. So we would store it as an n, indicative of none. Okay, it's important that we store these none variables because they tell us basically when the path stops. And then remember it's parent left right, so we look at parent 2, left child none, and right child will be none also. Okay, now we go back up to 1 and we look at the right child finally, 3. Look at its left child, 4, and since 4 does not have a left child here, we do none, and no right child, so we do none. And then we look at 3's right child, so it would be 5 and an n and an n. Okay, and then remember these none objects don't have any left or right children. Okay, so this is how we're going to serialize. And to deserialize, okay, so basically to deserialize we're going to go through this. We're going to convert this string input, so this would be a string right now, comma separated. So we convert this into an array, so that look like 1, 2, n, etc. character array. And then basically we create a node, we go through the positions of this array. Okay, we go in the forward direction through the different positions. So right now it would be if we are at position 0, so we create a 1 node here. Okay, and then we go to position 1 next iteration. This is going to be a recursive function. Okay, and we know we did pre-order traversal where we visited parent, left child, right child, so obviously the next position would be a left child, so 2. Okay, and now we have to look at 2's left child. Okay, so now we look at position 2 of the array, 0, 1, 2, and it turns out it's none. Okay, so I wrote n here, but basically 2 doesn't have a left child, and that's how we know we're done with this path here. Okay, we don't have to go beyond here. Okay, great. So we look at this position, and let's look at this position here, position 3. we know we'll be looking at 2's right child, because remember we did pre-order traversal up here, so we kind of have to match it down here. So 2's right child would be none. Okay, so this path is done. This path here, this is none. Okay, and then we have here 3, 4, you know. So now we look at 1's right child, which would be 3. Okay, and then 3's, and we'd be like position 4 right now, and then 3's left child would be 0, 1, 2, 3, 4, 5, position 5, and etc. Okay, and yeah, that's how basically we're gonna construct or deserialize our binary tree here. And this position counter would be a global variable. Okay, it would not be dependent on. It would be the same on every recursive call, so it would not differ upon independent recursive calls. Okay, so if we do like a recursive call, we don't want position to differ. We want it to be consistent because we're going through the array here. Okay, and both of these operations take O of n time because we're visiting each node / element once. Now to code this up, so what I'm going to do is define my array here, and then my helper function, which will be a pre-order traversal of the tree. So serialize tree to a string, and our base case is going to be if root is none, then array dot append n. Okay. Or else what we're going to do in our pre-order traversal here is append our string version of roots.val. Okay, remember we have to convert to string because self.val is an integer. And then what we're going to do is traverse the left subtree, and then the right subtree. And yeah, that's pretty much it there. And then what we're going to do with the array here is convert it to string. So result string equals, I'm going to have a comma separated. What's the syntax for it? It's not join. And then we're going to return that. Okay, so that was simple enough. Now for deserialize, what we want to do now here is first initialize our global position variable, which is at 0. So remember, data is going to be so right now data is a string, so I guess we want to convert that into an array. Data.split. Okay. So we do that. Now data is an array, so position is at position 0 of the array. So now let's define our helper function, which will help us using this position. We'll go across the array and build our nodes and build a tree there. So our base case here is if data at that position is equal to n, or not none, n. What we want to do first is increment self.position, and then return Okay, so imagine we have our data array here with 1, 2, n, 3, 4, n, 5, n. So this is our pre-order traversal here. We serialize this tree here with the pre-order traversal. So basically, we be at position 0 and we create a node here. So node equals tree node at, and we have to convert it to int here. Okay. So we're at position 0, and then what we want to do now is, since we already created a node at a position 0, we want to increment to position 1. So dot position plus equals 1, and then node dot left is going to be helper, and node dot right is going to be another recursive call to helper, and then finally return node. Okay, so we create a node out of this, we incremented the position of our array to this, and then we call node.left. Okay, and then node.left would be, then we create tree node with value 2. Okay, that would be the left child of 1 here, and then we increment. Okay, and then we call node.left again, and then we hit the space case here, and we're at n right now. So what we do is increment and return none. So now the left child for 2 is now none, and then we call node.right. And remember, during our base case, we already incremented our array variable, or our position variable here. So we're at this second n, and 2's right child is now n. Okay, and then finally we return the node with the value 2. And then in our recursive stack, we go back to our 1 variable, and we assign 1.left is the node with value 2. And then we do the same thing for right. So remember, okay. And at this point, by the time we call this right variable, our position would be here. And yeah, that's pretty much how we go about it to deserialize. So now we return helper. Okay. I'll try compiling this. Let's see what happened here. Converted it to int, and data, converted data to array. Converted that to background string. Return looks right. Should make a difference. I'll try anyway. Turn results to return. I forgot to return in this case here. Try again. Okay. Oh, I didn't call, of course. Okay. And I'll try submitting. Okay, great. Thanks for watching.